Hey guys, so today when I went to do my challenge problems with the honors class, we only got one problem done. And that's because it required a lot of background information to be able to get there. So I'm going to go over the background information in a separate video to actually solving the problem, um, just so you can watch them. That's why it's not all one big long video. Okay, where we need to make sure we understand is we need to make sure we understand how to do the distributive property. So this is a classic kind of setup for a standard distributive property question, where we're just going to take the outside number and distribute it by multiplication across the two inside numbers. So 7x times 3x gives me 21x squared. And then 7x times negative 5 gives me negative 35x. Classic process of distributive property. We've seen it many, many times. Hopefully everybody understands where that came from. Now, what we do need to know, however, to do is what happens if we want to go backwards. So what if I gave you something that looked like this? And I want to know what we started with. What was up here in the parentheses? So you got your parentheses, you got your number on the outside. What was up here that when I distributed, I got this value? Well, the reality is there's multiple correct answers. There's not just one. I mean, for instance, if I would have had a 2x out here, inside I would have 9x cubed plus 12x. If I distribute that, 2x times 9x cubed is 18x to the fourth, and 2x times 12x is 24x squared. It perfectly gives me that. However, this process of going backward is called factoring. And what we want to do is not just take out any one that works, we want to take out the largest one that works. So what's the greatest common factor? What's the biggest thing that's in both of these? And if that's what we're looking for, then it's 6x squared, and then this is a 3, and this is a 2, and then there's no x here at all. And so now we started here, but instead of going, again, from here to here, we went from here backward, and we got the biggest one possible. That is the process of factoring, and it's a first step in factoring. And anytime anyone ever asks you to factor, I don't care whether it's me or somebody else, if anyone ever asks you to factor, the first thing you should do is take out the largest possible factor and set it out in front. That's how we start. Now, then this moves on to distributive property like this, where we now have two terms to distribute. It's the same idea. It's not any different. It's just you're doing the distributive property twice. So you take the x times the x, and you get x squared. Then you take the x times the 9, and you get 9x. Then you take the negative 4 times the x, and you get negative 4x. And then you take the negative 4 times the 9 and get 36. And then, of course, we're not done because we have a common fact. We have like terms here in the middle. So we're going to have, to finish up, we're going to have x squared plus, now 9x minus 4x is 5x minus 36. So we have use the distributive property. We use the distributive property to multiply two binomials. You might have heard someone in a previous class use the term FOIL. I'm not a fan of that term. FOIL is only useful on binomials, so I don't really ever talk about it. But if you've heard that term before, that's what they're talking about. They're talking about this very process. Well, again, we're going to talk about this going backwards. What if I had x squared minus 8x minus 48. What was back here? What did I start with? What was the beginning of this problem because there were two parentheses up here. There was a binomial product that resulted in my answer. And how did I get there and what is it? Well, from looking at this one, what we can clearly see is that these two numbers multiply for this last number. So again, I know this is going to be an x in here. I know it's going to be another x in here. I know one of them, by the way, they multiply to give me a negative. So I know one of them is a negative and one of them is a positive. Again, I don't know what their numbers are yet, but I know that that has to be the case. So they multiply to give me 36. Now, this 5 comes from the sum of those two numbers. So what I'm looking for is something that multiplies to give me 48, but then, or negative 48, but then adds to give me negative 8. So if I think about what multiplies, so I'm looking at the number 48, I'm like, okay, what multiplies to give me 48? Well, it could be 1 times 48. That multiplies to give me 48. It could be 2 times 24. That multiplies to give me 48. It could be 3 and 16. That also multiplies to give me 48. It could be 4 and 12. That multiplies to give me 48. It could be 6 and 8. So there's lots of choices. It's not just one option. There's multiple choices here. But I want one where if I somehow combine them by addition or subtraction, and again, because I'm adding a positive and negative, I'm going to find their difference. I'm looking for ones that differ by 8. And that one is right here, 4 and 12. They differ by 8. Now, to get the negative 8, I need the 12 to be negative and the 4 to be positive. And so now I have factored. I went backwards. If you multiply this out now, you will see the x squared, the plus 4x, the minus 12x, the minus 48. You'll see how you got there. That process is required in dealing with quadratics. It helps us solve them. Well, how does it help us solve them? Well, if you put equals 0 here, and you say, okay, I'm going to factor it. So now it says equals 0. How is that going to be a solution? Well, the reason is there's a special property when things multiply to give me 0. If you take a times b equals 12, you don't know anything about a or b. They could be literally anything. They could be positive, they could be negative, they could be fractions. You have no idea. However, if you say a times b is 0, well then that means that either a or b is 0. So one of these two things has to be 0. Well, what x would I put in here to make this 0? Well, clearly that would be 12. If I put 12 in there, if x is 12, then 12 minus 12 is 0, and I'd multiply by 16 and I get 0. The other option would be what if x was negative 4? Because if I put in negative 4 plus 4 is 0, negative 16 times 0 is also 0. So this is how we use factoring to solve quadratic equations. And that's super important in this problem. And it's going to be a main thing we're going to see a lot in this class.